Explaining the procedure, now let's go into gram staining proper. The first thing is materials we're using: inoculating loop, we have our staining reagent, we have the bacterial cell, and we have our spirit lamp, and we have our glass slide. First, we sterilize our inoculating loop in direct flame until it's red hot. Then we'll cool it and put a drop of sterile water on our slide. Then you flame again. Each stages you have to flame your inoculating loop to avoid contamination or introduction of foreign organisms. Now after flaming, you cool your inoculating loop so that you don't kill the organism. This is a bacterial cell. You pick a little aliquot from the bacterial cell. Then you make a smear on the still, or a drop of the still water that you have on the glass slide. You are spreading the bacterial cell so you have an even distribution, so it will not just be congested in one place. We repeat the same thing. You flame, you cool bacterial cell, then you pick small organisms, bacterial cell, small aliquot, and you make a smear. You emulsify the bacterial cell with the still water to make a smear. You are spreading the bacterial cell evenly, so you can have an even distribution of the bacterial cell. Then each time after using your inoculating loop, you always sterilize before dropping it until it's red hot. Then you can drop your bacterial cell. Now, you allow your smear to air dry before you start staining. The bacterial cell smear that we made as air dry, we heat fix. You pass it through heat. You heat fix the bacterial cell so that to kill the bacteria, and then to allow the bacterial cell to stick to the slide, so that when you are staining, bacterial cell will not be washed off. So it fix so the bacterial cell can stick to the slide. It won't be washed off when you are staining. Now we want to start the staining proper. Now the first thing you do, you flood your smear with crystal violet or gypsum violet. It's a primary stain and it's purple in color. You flood your smear with crystal violet and allow it to stay for 60 seconds so that the bacterial cell can adapt to the stain, can absorb the stain. Actually, what we are staining in bacteria cell, in gram staining, what we are actually staining is the bacterial cell wall. It's the cell wall we are staining in the bacteria. And bacteria cell wall is made majorly of peptidoglycan and other structures. For gram-positive bacteria, you have majorly peptidoglycan structure, about more than 70% of the cell wall. For gram-negative bacteria, about less than 10% of the cell wall is made up of peptidoglycan. Once you rinse your bacteria, you rinse your smear. You rinse with running tap water. So that can stop the staining, and you add Lugos iodine. Lugos iodine is a mordant. It allows primary stain to form a complex with the bacterial cell. So you leave it for 60 seconds for Lugos iodine to form a complex with bacterial cell and the primary stain. After 60 seconds, you rinse with running tap water and add the chlorizer for a few seconds. You add the chlorizer for a few seconds. Now, if it's a gram-positive bacteria, the chlorizer will not be able to remove the primary stain. So it will retain the primary stain. But if it's a gram-negative bacteria, the colorizer will remove the primary stain. So it will be colorless and it will now pick the secondary stain. Now, after adding the colorizer, you rinse with water. As I said earlier, if it's a gram-positive bacteria, the primary stain will have formed complex with it that you cannot remove with the colorizer, so that when you add a counter stain, you add a counter stain for 30 seconds now, it will not pick the color of the secondary stain, which is a counter stain, that is safranin, because it has picked the primary stain. But if it's a gram-negative bacteria, it will be washed up by the colorizer and it will pick the secondary stain. We rinse with water and examine under the microscope to know if it's a gram-positive or a gram-negative bacteria. I said earlier that gram-positive bacteria has a cell wall that is made majorly of peptidoglycan. Over 60% of the cell wall is made of peptidoglycan. So when you add primary stain, it will pick the stain. When you add Lugos iodine, which is a mordant, it allows the stain to form a complex with the bacterial cell. When you add the colorizer, it will not wash off the stain because it's a gram-positive bacteria. And then when you now add the colorizer, a counter stain, it will not pick the secondary stain. But if it's a gram-negative bacteria, when you add crystal or gypsum violin to first pick the stain, Lugos iodine, it allows the stain to form a complex. But when you add the colorizer to it, because gram-negative bacteria has less than 10% of peptidoglycan, it has more of lipid, polysaccharide, which can easily be washed off by the colorizer, which is an alcohol. So it will be washed off and then it will pick. Since the primary stain has been washed off, it will now pick the secondary stain. And that's why gram-positive bacteria is purple in color. Picking this color of the primary stain. And gram-negative bacteria is pink in color, picking the color of a secondary stain or counter stain or safranin.